All right, so we're going to look at number 16 in section 3.1. And it says for the function f of x equal 1 over x, we're going to calculate these two expressions. These are basically difference quotients, different forms. If you remember, this is the form that we see in the limit definition of the derivative, and this one in the alternate definition for the derivative. But they'll both be instrumental in finding the derivative of a function by the limit definition. So this is just an algebraic problem. We're just going to simplify these expressions basically. Okay, so first of all, note that f of 3, if I plug in 3 here, I get 1/3. Okay, so what is f of x minus f of 3 over x minus 3? Well, f of x is just 1 over x. F of 3 is 1/3. And then we have x minus 3 on the bottom. Now, that's the difference quotient, but it's not simplified because I have fractions, smaller fractions within the bigger fraction. So how do I clear that up? Well, you could combine the numerator as one fraction, and then dividing by x minus 3 is the same as multiplying by 1 over x minus 3, and you can simplify it that way. I like to simplify by multiplying my big fraction by the least common denominator of all my smaller fractions. So this smaller fraction here has a denominator of x. This one has 3. We can think of this as being x minus 3 over 1. But the LCD of x, 3, and 1 is just 3 times x, or 3x. So I'm literally going to multiply both the numerator and denominator by 3x. Notice this whole expression, right, is equal to 1. We're not changing the value of our expression. And when I multiply up top by 3x, notice I have to distribute that through both of those terms. So I've got 1 over x times 3x and 1 over 3 times 3x, with the subtraction in between there. Of course, in the bottom, I've just got 3x times x minus 3. There it is, making sure you put that in parentheses. Now I'm going to leave the bottom alone. I'm not going to distribute because it's factored. Up top, it's not factored. In fact, I've got to do some simplifying, though. 1 over x times 3x. Well, 1 over x times 3x. Notice the x's will cancel. I'll just be left with 3. And here, the 3's cancel. I'm just left with 1 times x, or x. So this is what I have after I simplify my fractions. Now, can I simplify this at all? Well, some of you know how to do that. You see, I've got a factor of x minus 3 down here. Up top, it's 3 minus x. Those factors are not the same. Similar, close, but not the same. What's the relationship? Well, most of you know they're just opposites. In other words, if I cancel 3 minus x divided by x minus 3, or that expression right there, rather, is equal to -1. You can see it a little more formally. 3 minus x I can write as negative x plus 3, right? Because 3 minus x is the same thing as 3 plus a negative x, right? That's the same thing. And then I can add in any order. So 3 plus negative x is negative x plus 3. Factor out a -1 from these two, and I get negative the quantity x minus 3. So notice 3 minus x is just negative this factor. Excuse me. So I can factor both of these now, right? And I have top -1 over 3x, which is -1 divided by 3x. Okay? So there's the simplification of this one. Now we have to do this one as well. And there I need f of 3 plus h. So what's f of 3 plus h? Function is 1 over x. So replace x with x plus h. So it's 1 over 3 plus h. Notice it's not 1/3 plus an h. I get a lot of students that do that. Please do not do that. Okay. It's 1 over 3 plus h. So plugging in, f of 3 plus h, as we said, is 1 over 3 plus h. F of 3 we saw above was 1/3, and h is h. Okay, there's my expression. How do I simplify that? Well, like up above, I'm going to multiply by the least common denominator of all my smaller fractions. Well, here I have a 3, here I have a 3 plus h. This could be h over 1, so there's just a 1 down here. So notice there's no common factor between 3 and 3 plus h, so my least common denominator is just 3 times 3 plus h. I'm going to do that, of course, again to the numerator and to the denominator. Again, I'll just remind you that this is equal to 1, so I'm not changing the value of this expression. Therefore, it's equal, right? And then I want to do the distributing just like I did before. When I distribute up top, this 3 times the quantity of 3 plus h, when I multiply it by this fraction, the 3 plus h factors will cancel, leaving just a 3. When I multiply by this fraction, the 3's will cancel, leaving the 3 plus h. But be careful, put that in parentheses, because this minus sign is going to come through, right, and be distributed. So it's going to be -3 minus h, right? So 3 minus 3 minus h simplifies down to just minus h. In the bottom, don't do anything other than, keep it factored. H times 3 is 3h times the quantity 3h, 3 plus h rather. You could distribute the 3h through, but I would not do that. It's factored. Leave it alone, right? Notice again, the top simplifies down to just -h, and now, right, I can cancel this common factor of h. So up top, I got -1, and the bottom, I have 3 times the quantity 3 plus h. Therefore, a negative divided by positive, we can write this as -1 over the quantity 3 plus 3 over h. Okay, and so in both of these situations, we encounter, the difference quotient, which will be involved in evaluating the derivative. Now, if you wanted to find the derivative here, you would, for instance, if you're trying to find f prime of 3, you take the limit as x approaches 3. And as you can see, the limit as x approaches 3 of this expression would obviously give me -1 over 3 times 3, -1/9. Here, we would take the limit as h goes to 0. Notice the limit as h goes to 0. What happens if h goes to 0? That's going to be 0. I've got, again, -1/9. So that would be the derivative. That would be f prime of 3. That they're not asking for you that for this in this particular problem. Okay, so there are the two results. Hopefully that makes sense. As always, if you are in need of more help, please let me know.